So probably some of the most interchangeable functions are the exponent and radical functions. And if you understand the key components of each, it should be relatively easy to translate one into the other. So if I start off with an exponential function here, this a value represents, sometimes people call it a base. And in other texts, you'll see it called a power. For this course, we're going to refer to it as a base. And the little number in red here, the b, that is going to be the exponent. And again, ironically, some other textbooks call this the power. But the base is the larger number, and the exponent is the smaller number on top. And what that means is, if I'm translating this to an actual example, if I have 2 to the exponent 3, that exponent does not mean that it's 2 times 3. It actually tells you how many times the number multiplies itself. And so if I were to expand this, this would actually be 2 times 2 times 2, not 2 times 3. And 2 times 2 times 2, the first 2 would give you 4, then multiplied again by 2, this would have a total of 8. So the exponent tells you how many times the base multiplies itself. Now, if we look at the radical function, this root over here, what that represents, it is a root, but really we call that the radical symbol. And so the minute that we see a root of some kind, we know that we're probably dealing with a radical number as long as it's not a perfect square. Now the white box over here, that would be the number that goes under the root, and we call that the radicand. And what that is really the number that is being rooted, whether it's cube rooted or square rooted, but this is the number that gets rooted. The last blue box over here is something called the index. And what that represents is the root that we are asked to find of the radicand. And so the number or the index will tell you whether I'm trying to find the square root of the number, the cube root of the number, the quintic root of the number. And another thing we should mention over here is that if it's a square root, if square root, okay, then no number is listed. But anything above a square root, like a cube root, or a quartic root, or a quintic root, that will be listed right outside in the top left corner. So in these two examples over here, I see that the radicand is the 27. The square root is just the radical symbol. And then I can see that the index is 3, which means that what I would be simplifying this as, or calculating, is the cube root of 27. Now, if I look at root 64, well, 64 is the radicand. And since there's no listed number here, we know, for the index, we know that this is a square root. And so if I were to actually assess each one, well, the cube root of 27 is 3. And that just means that 3 times 3 times 3 is going to equal 27. And the square root of 64 is 8. And that's because 8 times 8, or 8 squared, if I were to rewrite these in exponential form, 8 squared, that would equal 64. So for this video, that's all we're going to look at. We're going to do conversions from the radical form to the exponent form and exponent form to radical form in a separate video. But this really is to give you the idea of all the properties, or not the properties, but of what each thing stands for when we're looking at an exponential and radical function.